Welcome to Algebra 2, and today we're going to be talking about Section 5, scatter plots. So first off, we're just going to draw a scatter plot. The information in this table shows the median selling price of new, privately owned, one-family houses between the years of 1990 and 2000. So what we're going to have to do is we are going to have to decide which variable is going to go on the x and which variable is going to go on the y. Well, year will be our x variable because that is independent. It can stand on its own, and the price will be our y variable. So we're going to label that. So this is year, and our y will be price. We also want to make sure we go up by even increments. So our years, we go from 1990 all the way to 2000, and we appear to be jumping over years every time. So if I start here and make this one 1990, I'll make this one 92, 94, 96, 98, 2000. Price, our lowest price is 121.5 and our highest is 169. So if we just think about that, it gives us about a range of 50. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We got 16 spots there, which means we can probably go up by about 5 each to make it work. So we'll draw the jump. We're jumping some here, and we're starting at 120. There's 130. There's 140. There's 150, 160, and 170. So now we should be able to plot these points on here. So in 1990, we have 122.9, and we're just going to have to do our best job of approximating where that is. So be right about there. In 1992, 121.5, once again, just doing our best job to approximate where it is, about there. 1994, 130. 1996, 140. 1998, 152.5. Right about there. And in 2000, 169. So right about there. So there we drew the scatter plot. And that should be something you're all fairly familiar with. So next up, we're going to draw the line of best fit. The line of best fit is the line that best approximates the data. So what you're going to have to do is you're going to have to take a ruler. You're going to have to take this ruler and rotate it around until you get a line that best actually approximates this data. So you wouldn't just pick the first point and the last point and line those two up, because if you did that, we would have not all the points would actually be on the line. So instead, whoopsies, I'm moving the graph. So instead, you want to just make sure that you take your ruler and you line it up going through the points so that some end up being above the line, some end up being below the line, but this just best approximates where this would go. So I would maybe line the ruler up about like so. That looks pretty good. I might want to tilt it just a little bit more. And then using your ruler, you're just going to draw a straight line through those. And I can't get the ruler to move quite how I want it to. So I'm just going to adjust it quick here. About there. So you're going to take it and you're going to draw the line right on that straight edge of the ruler. And your lines will obviously be beautiful and straight because you have an actual ruler instead of a virtual one. Get rid of that. So there is the approximate line of best fit. Okay, so your line should go through most of the points. All right, you want them to go through most of the points, and you want it to just be a good approximation of what's happening here. All right, so next, we now are going to find the prediction equation. The prediction equation is just the equation of the line of best fit. Okay, so in order to find the prediction equation, you need to find the slope of the line. So you're going to take a look at your line and you're going to pick the 2 points that are closest to this line. So in this case, I would have to call it this point and this point. So in the year 1992 and the point from the year 1998. And my labeling got a little messed up there, so I'm just going to fix that quick. So in the year 1998 and 1992. So I'm going to take these two sets of points, and we are going to make a prediction equation for that. So in 1992, it was 121.5. So 1992, 121.5. And in 1998, it was 152.5. So to find a prediction equation, we first find the slope. So slope, y2 minus y1. So 152.5 minus 121.5 divided by x2 minus x1, 1998 minus 1992. Well, 152.5 minus 121.5 is 31. 1998 minus 1992 is 6. So now this has a slope of 31/6. Now, I know that we've kept everything as a fraction up to this point, but when we're finding prediction equations, we actually want to approximate these. So we will be writing this as a decimal. So this is approximately 5.12. I'm sorry, 5.17. 5.17 is what it is approximately. This is because when we're comparing our equations to one another, 31/6 is going to look very different than, say, 25/4, but they are actually pretty darn close to being the same thing. So we want to make sure that we are doing an approximation to the nearest hundredth. So there we found the slope. Step 2 then is we're going to use this in point slope form. So y minus y1 equals m times x minus x1, and then we'll get it into our slope intercept. Well, you can pick either point, so I'll pick the 1992 point. So I'll say y minus 121.5 equals my slope, which is 31/6 times x minus 1992. And right here, I'm still going to use the exact right here so that I don't lose all of these decimals, because that was a 0.16 repeating. But once when I distribute this through, I'm going to change it into decimal form. So we have y minus 121.5 equals, distributing this, we have 5.17x minus 1992 times 31/6 ends up giving us 10,292. Solving for y, then, we would have to add 121.5. So we have negative 10,292. We add 121.5. Our equation is then y equals 5.17x minus 10,170.5. So this is our prediction equation. Okay? Next, we're going to use our prediction equation to predict the median price in 2010. Ooh, who found my typo? There's definitely a typo. My bad. All right, so we're going to use this prediction equation to predict the median price in 2010. So the year is 2010. We want to predict the price. So recall, years were our x values, price were our y values. So that means we're going to plug x in to be 2010 in our prediction equation. So y equals 5.17 times 2010 minus 10,170.5. This is just a plug-in and chug-in. So you're going to take this in your calculator, and you're going to calculate that y is 221.2. Now this is price. We have to refer back to our table. This price was in the thousands, so we want to make sure we're writing this correctly. So we would say that the median price in 2010 should have been 221,200. Now, of course, you can go and check that with, look up some data and see if that's correct. I can guarantee that that was not the median home price in our Toma area for sure. We were much lower than that.